Hello guys, and now we are going into cubics, the big boys. So for cubics, we know they're made of x to the power of 3, and I can give you a basic example, which is maybe x plus 1 times x minus 1 times x plus 5. So that is the x-intercept form for cubics. So now we expand this. We have, this is going to take a long time. X minus x squared minus 1 times x plus 5. We have x cubed times 5x squared plus 5x squared, take away x minus 5. So this could be one of the questions you will get on the exam. It's letting you sketch the graph. So you have y equals x cubed plus 5x squared minus x minus 5. So how to solve this is very simple but also very annoying. So it's basically you make x equal to a number. We use a instead. So you make x a constant and you sub it in. So this is f of x equals to blah blah blah. So you could have x equal to 1. Assume x equal to 1. So f of 1. And because we got the equation from that, so we know f of 1 equal to 0. So you basically you assume a number and you get 0 here. Because this is exam, not a real life condition, so they would normally choose the number from -5 to 5, or just integers. So after you've done this, if you chose x equal to 1, and now you say x minus 1 is a factor. So when x equal to 1, the factor is x minus 1. It's like the reverse of when you get this, you know x equal to 1. So x minus 1 is a factor. Then you do the long division. And you have x cubed plus 5x squared minus x minus 5. And you have x minus 1, and I won't do the long division except you ask me to. And yeah, this is how to find the x-intercepts with your hands. And y-intercepts are simple and easy. You make y int, you have to write this y int when x equal to 0, and you sub it in, you get -5 for this case. So they wouldn't ask you to find stationary points, except they give it to you in this form. So if you see the bracket with power of 3, you know that is the value. That is the x value of the turning point, of the actually stationary point of inflection, and this is the y value. So we could have 2x take away 1 cubed plus 3, and now the stationary point is 1, 3. That's basically it for cubics. But in exam 2, it might ask you for something you wouldn't be trying out. So in exam 2, you can use your CAS calculator. So you press the button. So menu, and you press the number 1. Wait, no. Menu, you press the number 3, menu, algebra, and you press the number 1. You have menu, algebra, solve. You put y equals to blah blah blah, or f of x equal to blah 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 in, and so you'll have in the CAS calculator like solve bracket, and you put in the equation equals to blah blah and comma x, and it gives you the x values. And using the CAS calculator, you could also go menu, algebra, I think the second one is expand. Well, just go expand, and you can put this in. So you basically menu 3 2, and put this in and just press enter, and you get the equation after expanding. And another technique for using this is, if you want to graph it out, you could go to the graph. So you know how in your calculator there's this window, and you have the top ones and you have the bottom ones. You have the bottom ones. So that one would say calculator. That one would say graph. Never go those two. Always do this one or that one. This is calculator, this is graph, this would say geometry. So always go these two. So after you press these two, you can see in there when you graph, it says f1 of x equals to something. So if you put that in, if you put the equation in, it automatically graphs and defines this equation as f1 of x. So when you press, when you're in the same document, when you press calculator, so if you put f1 of 0, is automatically giving you the y-intercepts. Is that nice and easy? Yes, sure it is. Okay.